Good morning, good afternoon, good evening, ladies and gentlemen, wherever you are around the world. Thank you for joining us for today's Siemens Global webinar. Today's topic will be looking at optimizing your product design for light weighting. We have two speakers for you today, Mr. David Chadwick and Mr. Jim Wright. Their bios are up on the screen. I'll just touch on a couple of things. David is a business development manager for Solid Edge portfolio. And is focused on industry solutions from that portfolio. He has over 30 years of application engineering, project management and marketing experience, and has been involved in many successful PLM implementations, small, medium-sized manufacturing organizations all around the world. So very warm welcome to Mr. David Chadwick. Following up from David, we have a video presentation from Jim Wright, who's a business product manager for manufacturing mainstream engineering. Just to tease out a couple of bits, he works in global technical business development as a CAM mentor, and through those two roles, spearheads manufacturing initiatives for mainstream engineering. Again, he has over 30 years of experience in this particular area. I would like to remind you that Jim will be on for the Q&A, so please feel free to go ahead and type in your questions, anything that may come up. But without further ado, let me go ahead and pass over to your first speaker today, Mr. David Chadwick.
Thanks, Jay, and it's good to have this opportunity to talk with you all today. I just have a few slides before we get to the demonstration to put the issue of lightweighting in a wider context of trends we are seeing in manufacturing. One of the main issues we see today is that manufacturers are faced with increasingly complex requirements from their customers. This is being driven by a variety of different needs. For example, the need to manufacture products that are customized to meet the demands of specific end users, the need to connect products to the internet, and the need to meet increasingly demanding environmental regulations. And this is in an environment where existing supply chains are under pressure from an unstable environment around tariffs and threats to production from global health concerns. The area that we will explore today is the pressure to design and manufacture products that minimize weight and material usage, products that reduce energy consumption, and that enable you to differentiate yourself from your competition. Irrespective of the type of products you design and manufacture, we believe that digitalization is absolutely essential because products are becoming more complex, multifunctional, and incredibly sophisticated. In this example, the modern sewing machine shown on the right now includes a touchscreen interface, sensors to detect material location, and it is connected to the internet to download patterns and report on maintenance issues. So, products have changed, the market has changed, your customers have changed. Have your engineering processes evolved to meet these changes? A key part of the solution proposed by Siemens is to create a digital twin of your product. The digital twin can be used as a basis for all areas of product development, including, for example, managing customer requirements, detailed design, lightweighting, simulation, manufacturing, installation, and service. Creating a digital twin of your product helps you address the challenges you face to bring new products to market quickly and efficiently. Today, we are going to focus on lightweighting and specifically how new technologies in the areas of generative design and additive manufacturing can help improve your product development process in this area. One of the unique technologies that we use to support lightweighting and additive manufacturing is called convergent modeling. This technology works behind the scenes to combine design information stored in mesh-based models, for example that created by reverse engineering, or that created by the generative design process that you will see in the upcoming demonstration, with that stored in the boundary representation format of traditional 3D CAD models. Using convergent modeling, designers can work flexibly and interactively on CAD models that use one or both of these modeling techniques. At this point, we'll hand over to Jim Wright for his discussion and demonstration of lightweighting.
Hi, welcome to our webinar on lightweighting with generative design. Just what is lightweighting? Lightweighting is the reduction of component weight in a product, resulting in a lighter overall design. There are multiple ways to achieve lightweighting. The benefits of lightweighting are improved performance, reduced environmental impact. It also saves precious material resources. In other words, we can make more of the same product using less material. Some products that can benefit from lightweighting: airplanes, railroad locomotives and cars, automotive, shipping, consumer goods that move. There are some areas where lightweighting is not beneficial. For example, when I buy gold coins, I don't want them to be any lighter than they're supposed to be. There are some things we need to understand about generative design. For one, it generally creates an organic looking design, similar to a bone structure in a skeleton. It is an excellent lightweighting tool. It may be even the very best method to reduce material to a bare minimum. However, it does limit manufacturing processes. A full-on generative design, at least the ones I've seen, can only be made by 3D printing. Also, it's not suitable for every purpose. For an example of that, Google when generative design backfires, and you'll see what I mean. We will discuss several lightweighting techniques in this webinar: material substitution, and of course using generative design for lightweighting. We will also explore replacing an assembly with a single component, and using generative design as an idea machine. Finally, we'll end with a demo of generative design. Let's talk about material substitution. The bicycle is a classic example of material substitution. When bicycles were first designed and used, they were made of steel. However, as time and material technology got better, we switched to aluminum, and then titanium, and now many modern racing bikes are made from carbon fiber. In each iteration, the bicycle became lighter and just as strong as the previous design. That results in less energy expended by the rider so that he can maintain the same speed or even go faster. Lightweighting with generative design. Here's an example of using generative design for mass removal in an airplane. This airplane seat support was able to experience a weight reduction of 45% and yet exceed the original design strength simply by using generative design. Even though the part was originally aluminum, which is a lightweight material, we were still able to reduce that by 45%. That may not seem important, but if you think about the number of seat supports that are in a typical airplane multiplied by the number of miles that airplane will fly in a typical year, that's a lot of savings on resources to propel that airplane. We can also do lightweighting with manufacturing restrictions. What this means is we're going to design or orient the direction and orientation of the actual print process itself. We can also protect certain areas that maybe we'll machine later on. So this can be a combination of both additive and subtractive manufacturing processes coming together to produce an acceptable part. What about replacing an assembly with a single component? We have an example for that also. This comes from the automotive industry, where we replaced a multi-component assembly into a single model. We reduced the labor cost of the assembly, we also reduced product complexity, and we reduced inventory cost. This particular gas pedal was previously made of 4 components, all made from sheet metal. As you can imagine, the sheet metal process requires them to be cut out of a sheet and then bent into shape and then finally welded together. By converting that to a 3D printed object, this allowed us to eliminate 4 components, replace them with 1. We eliminated the sheet metal manufacturing process. We also eliminated the welding process. Oh, and we also changed the material from steel to aluminum, allowing us to reduce the weight of the overall assembly by 62%. Let's count the components. First is the bracket at the base, then the support for the pedal itself, next is the pedal top, and finally the pivot. 62%. That's pretty impressive. Now here's an approach that you may not have thought of. What about using generative design as an idea machine? Going back to our aerospace example, we created a generative design of the part, but then because we wanted to maintain original traditional manufacturing methods, we simply modified the design so that it looked similar to the generative design model while reducing weight. This allowed us to reduce the overall weight by 30% while still maintaining traditional manufacturing methods. Okay, let's take a look at a demo of generative design in Solid Edge. Let's begin a generative design study on our seat support structure that we see here. First, we'll create a generative design study. Then we'll bring the generative design pathfinder out and lock it into place. Next, we'll apply a fixed constraint to the bottom holes of our seat support structure, as these holes will have bolts run through them that are attached to the floor of the cabin space. This is a logical point for the fixed constraint to be applied. Next, we'll apply some forces. First to the top of the seat support structure in the down direction, and that will be about 65 Newton meters over a distance of 8 offset. Now this offset is important because what that means is this force will be applied to the top and the bottom for a distance of 8 millimeters. In other words, it will preserve that region of the geometry. Our next force will be applied in the forward direction on these bolt holes. So we'll pick this face because that's an easy way to get the force direction. And the force will be 35 Newton meters applied over about a 5 millimeter offset. And then we'll pick these holes as where the force is to be distributed. And then we'll deselect by holding down the control key this planar face. That's a nice little trick to give us the force direction in a very easy manner. Now, as you can imagine, as the plane is landing, there will also be forces applied side to side. So once again, we'll use our trick to pick this planar face so that we can quickly establish the force direction, but the real force will be applied to the bolt hole faces. So we can now deselect the planar face and apply a force of 35 Newton meters over that same 5 millimeter offset. Now, as I mentioned, the seats will be shaking from side to side, so we need to apply the same load to the other side of the seat support. Generative Design Pro allows these forces that would normally cancel each other out to be calculated separately. Deselect the planar face, apply a value of 35 Newton meters over a 5 millimeter offset. Finally, we want to preserve certain regions of this design, so we'll use preserve region to do just that. The large bores are important to keep, so we'll keep those with an offset of 5 millimeters, as well as the entire outside shape of our seat support. Preserve region does exactly what the name implies. It makes sure that generative design doesn't remove those faces. It leaves them in place. Now that we've applied our fixed constraints, our forces, and our preserve regions, we can now go in and apply some manufacturing constraints. The material for this will be extruded in the Y direction. We mostly want strut-like structures, so we'll move this all the way over to strut-like structures. And we also want to prevent overhang in the Y direction. Now we can move forward and select the generate options. Here we can set things like the study quality from low to high. The higher the study quality, the longer the study will take. We can also set the target mass parameters. We'll shoot for about a 30% reduction in weight, about 0.6 kilograms. We also have turned on hide the design space when the results are displayed. So now let's generate the design. In the interest of this webinar, we will compress the generation time. And there's our result. We can use the built-in stress results to see what stresses are applied in this particular part. But what if there's a better way? You know, many of the features that we put into this part when we first designed it were there to reduce weight. What if we eliminated those features and then allowed generative design to figure out how to best lightweight this part? Let's try that. First, we'll delete those features that were put in there for lightweighting purposes. Next, we will allow generative design to calculate a new body shape based on these settings. Because this body weighs more than the original body, we need to increase the amount of percentage reduction to get back to that 0.6 kilograms targeted weight. Let's generate that. And as before, we're running time compression to get to the results quickly. And here are the results of that second iteration. A pretty nice result. One of the great things about Generative Design Pro is we can actually detach this study and then treat it like a regular design body and make edits to it just like we would with any other body. We'll toggle Design Construction. And then activate this body. Now we can turn on a sketch and use that to cut through the body as we did on the prior design. This method allowed us to achieve a superior result in the generative design while still being able to maintain those features that we wanted to have designed in. Oh, and by the way, as you can see here, a generatively designed part works fine in the context of an assembly. You can mate features to it and perform other tasks as well. The basic generative design package is available in both premium and classic solid edge seats, but not foundation. This chart shows some of the differences between the Generative Design Standard package and Generative Design Pro. Generative Design Pro features things like advanced loads, advanced design constraints, stress plots, an unlimited number of studies, and also multiple load cases. In other words, compression and tension don't necessarily cancel each other out. It also supports the manufacturing constraint dialog that you saw, and the design geometry can be output directly for 3D printing or editing. Okay, that's it for me. I'm Jim Wright, and I'm glad you attended this webinar.